Hello guys, so in this video we are going to discuss the solution of the problem Techfest and the cube. So let us understand the problem statement. So the problem statement says is that a Techfest is underway and each participant is given a ticket with a unique number. Organizers decide to award prize points to everyone who has a ticket ID between A to B, A and B, and A and B inclusive. The points given to a participant with ticket number x will be the sum of powers of the prime factors of x. So let us understand what does that mean. So for instance, if the points are to be awarded to a participant with ticket number 12, then the amount of points given out will be equal to the sum of powers in the prime factorization of 12. So the prime factorization of 12 will be 2 squared into 3 to the power 1, and the power is 2 and 1. So the point awarded to this participant will be 2 plus 1, which is equals to 3, right? And our objective is to, given A and B, determine the sum of all the points that will be awarded to the participants with ticket numbers between A and B inclusive. So let us take a look on the example. So for instance, if A is 9 and B is 12, then 9, the prime factorization of 9 is basically 3 square. So the sum of power here is 2. And similarly, so 9 to 12, so 9, 10, 11 and 12. So the prime factorization of 10 is 2 into 5 and the powers are 1 and 1. So the sum of power will be 2. Similarly for 11, it is just 1. So the sum of power is 1. 12, it is 2 square into 3. So the sum of power is 2 plus 1, which is equals to 3. And our answer will be, so the answer is basically the total sum, which is equals to 2 plus 2 plus 1 plus 3, right? So that is equals to 8. Okay, so that's about the problem statement, folks. Now let us look at the solution for this problem. So in order to understand the solution of this problem, we need to understand a concept which is basically, given a number n, if we have to list down all the prime numbers which is less than or equals to this number, right? So given a number n, we want to list down all the prime numbers which is less than or equals to n. Then there is an algorithm for this, and that algorithm is basically this Sieve's algorithm. And let us just quickly understand this algorithm, because we will be using this algorithm in our solution. So in order to do so, let us say in this particular case n is equals to 100, and we want to list down all the prime numbers which is less than or equals to 100. So the way we are going to do is basically, we are going to list down all the numbers from 2 to 100. Okay, and then we are going to set our counter, or the iterating counter, to the initial point, which is 2. Okay, now since 2 is an uncolored item, then we are going to maintain a list of prime factors, and we are going to append 2 to the list of prime factors, right? So basically the idea is the uncolored items will be my prime factors. So right now 2 is not colored, so we are going to append 2 to the list of prime factors. So now 2 is a prime factor. The next step is basically, we are going to color all the multiples of 2 by a certain color. So basically all the multiples of 2, so that would be 2, 4, 6, 8, 10 and so on. So all these numbers we are going to color it by a certain color. What color doesn't matter. So we are going to color it, and once we have colored it, we are going to increase our iterating counter to the next element, which is 3. Now again 3 is an uncolored item, so we are going to append it to our list of prime numbers. So 2 and 3, now the prime numbers are 2 and 3, and we are going to repeat the same process. We are going to color all the elements or all the multiples of 3 with certain color. Okay, so now the prime numbers are 2 and 3, and we have colored all the multiples of 3 by blue color. Now we are going to increase our iterating counter. So we have increased our iterating counter to 4. Now since 4 is a colored item, so we are not supposed to do anything over here. We are just going to increase our iterating counter, right? So whenever we see that we are visiting a colored item, we are not supposed to do anything. We will just go ahead and increase our iterating counter. So now my iterating counter is on 5. 5 is an uncolored item. So we are going to append 5 into the list of prime numbers. Okay, so now the list of prime numbers contains 2, 3 and 5, and we are going to color all the multiples of 5 by certain color. Okay, so we will do so, and this will be the result. So what we are going to do is that we are going to keep doing the same process, and by the end of it, when we have exhausted all the elements, by the end of it, this particular list will contain all the numbers, or all the primes. So this particular list will contain the list of prime numbers. So that's the Sieve's algorithm. I hope that makes sense, and we will be using this in our solution. So now let us discuss the solution for this. So let us discuss the solution of our problem. So let us take an example. So let us take the same example, a equals to 9 and b equals to 12. So the first thing we are going to do is basically using Sieve's algorithm, we are going to compute the number of primes less than or equals to b, right? Or rather than number, we are going to uh, maintain a list of primes less than or equals to b. So for in case of b equals to 12, the list of primes would be, right, the list of primes will be basically, let me just have it over here. So 2, 3, 5, 7 and 11. So these are the prime numbers which are less than 12. Okay, less than or equals to 12. Okay, so once we have this, what we are going to do is basically for all element in the set A to B, A and B inclusive. So for the first case, A will be what? A is 9. So for the first case, element will be equals to 9, right? So what we are going to do is basically this element and this prime. We are going to see whether elements of prime divides this. Okay, let me just call it as x. So elements of prime divides x, right? So basically what I mean to say is, so the x is 9, and the prime we have, the list of prime which we have is basically 2 is also there. So 2, 3, 5, 7 and 11. So we are going to check whether 2 divides 9 or not, right? We are going to check whether 3 divides 9 or not. We are going to check whether 5 divides 9 or not. We are going to check whether 7 divides 9 or not. We are going to check whether 11 divides 9 or not, right? So for the cases, so for instance, like clearly this does not divides, this does not divides, this also does not, and this also does not divide, right? So for the case where it divides, where it divides the number, what we are going to do is basically we are going to compute how many factors. So for instance, this is 9 is basically equals to 3 into 3, right? So how many times does 3 divides 9 is something we are going to compute. So that is basically, in this particular case, it is 2, and the we will be maintaining a factor variable. So factor variable. So for the case of 9, 3 is the only factor, and and 3 divides 9 2 times. So basically 3 is square, right? so that this information will be there in the factor variable. Let us take one more example in order to understand this. So for instance, let us say that the element or the x is 12 here. So 12 is basically, we know that 2 is square into 3, right? This is what 12 is. And the list of primes which we have is basically 2, 3, 5, 7 and 11. So the first thing we are going to check is basically whether 2 divides 12 or not. So in this particular case, this 2 divides 12. Now what we are going to do is basically we are going to see how many times does 2 divides 12. So for the first time when it divides, it becomes 6. For the second times when it divides, it becomes 3, right? So now clearly 3 is not divisible by 3 does not divides 2 does not divides 3. So here, since it divides 2 divides 12 2 times, so that is why the factor will be 2 here. Okay, so now the new element has been reduced to, so now the x has been reduced to 3. So now the x has been reduced to 3, and we will see. So we have operated on 2, now we will move on 3. So we will check whether 3 divides 3 or not. 3 divides 3. So clearly this is possible, and 3 divides 3 just one time, right? So that is why the factor variable will be increased to 3. Okay, now the next element, now the x is equals to 1 after this manipulation, and the next element in prime is 5. Clearly 5 square is less than 1. So in that case we will break this loop and we will come out of it. And basically what it says is that the factor, the number of the sum of power of prime factors which divides 12 is 3, which is the case we wanted to get, right? 2 plus 1 equals to 3. Okay, so that is how this is. And this will be more clear once we get into the coding aspect. I'll be able to explain it over there, and hopefully that will make more sense to you. So now let us jump to the coding section. Okay, so see, this is what we want to do, sum of powers, okay, a to b. So first thing we are going to do is that we are going to compute the prime factors and prime factors of b. So that is what we are doing, and this function does that. Now let us look at this function. So this is basically Sieve's implementation of that function. So right now we will start with primes, which is like the numbers from 2 to 100 in the example which we have. So this number basically from 2 to 100, right? So this number is there in our this list, primes list, and by default we will set its value to true. And after the processing, the only those values will be true which are prime. Otherwise all other elements will be set to false. Okay, now let us see how we are going to do it. Now this is basically I into I is less than or equals to n. Okay, since we want to compute the primes here, so remember the prime will exist till square root of n, and this is the other way of writing it. So the square of n, square of I is less than equals to n. Now if it is true for now, then we have to investigate whether it should be true or not, and all the multiples of I we have to set it to false, right? So what we did is basically, so we start with 2. Now the 2 will be true, set to true, but all the other multiples of 2, which is like 2 into 2 is 4, then 6, 8, will be set to false. So that is what we are doing here. So we start from 2 into 2, right? The first 2 into 1 is already set to true, and we go to the next part onwards and we set it to false. So here all the multiples of 2 will be set to false. Similarly, when we'll see 3, all the multiples of 3 will be set to false, and 5 and 7 and so on, and all the prime numbers will be set to true. Okay, and once we have that, then we get our the list of primes over here, right? And we get the list of primes like this, and we return it. Okay, so by the end of this function, we will have the prime factors in our this array or this list. Now we want to compute the total number of factors or the cumulative number of factors for range A to B. Okay, so this is the range, and for I, right, and the prime factors, how many factors are there, which how many primes are able to divide I is something which we are going to check in this function, and this is how we do it. So the number of factors will be stored in this variable, and we start from all the prime numbers in prime factors. If square of that is greater than n, then we will break the loop, because now all the numbers beyond this point will not be a prime factor. We are sure of it. That is why we are breaking this loop. Otherwise, we'll see if it is a prime factor or not, whether it is a factor or not. If it is a factor, then we are going to the way I have explained it during the explanation, we are going to change n to n divided by p, and we are going to update our factor by 1. Toward the end of this loop, it might be possible that n contains a non-1 value or a value which is greater than 1. In that case, that value is a prime factor, and that in order to accommodate that, we are going to increase our factor by 1, and towards the end we are going to return factor, and then that is how we will get our entire count. So that's about the coding aspect of it. Now let us submit our solution. So our solution got accepted. So that's about from this video, folks. I hope that this is helpful to you. In case if you have any questions or concern regarding this video, please feel free to use the comment section, and I'll try to address them. Thank you.